What's up, YouTube? I have an interesting story about milk, right? It's not just any story, but it's a story that I tell a lot because I found that on days I don't exercise, I become lactose intolerant. And I want to know what can be going on, right? So I did some research, but before we get to that, I always thought that lactose intolerant means that your body can't produce lactase. Then recently I realized that there are other things that contribute to your body's ability to digest milk. So I asked Quality AI some interesting questions about my body's ability to digest milk. And this is what we got. So one of the questions I asked was to define lactase or lactose intolerance, right? So I asked it, what is lactase's function in the human body? Cite relevant sources in mammalian format. Lactase is an enzyme that is produced in the small intestines of humans and other mammals. Its primary function is to break down lactose, a sugar found in milk and dairy products, into glucose and galactose, which can be more easily absorbed by the body. Lactase deficiency, which is the inability to produce enough lactase to digest lactose, can lead to symptoms such as bloating, gas, and diarrhea. This condition is known as lactose intolerance. So I asked it further, what are some of the symptoms of lactose intolerance? And of course, I'm always asking it to cite relevant sources in mammalian format. The symptoms of lactose intolerance can vary from person to person, but may include bloating, gas, abdominal pain, cramps, diarrhea, nausea, and vomiting. These symptoms may occur within 30 minutes to 2 hours after consuming lactose-containing foods or beverages, right? And here are the sources for the symptoms, and then there are sources, of course, that I asked for about lactase's function. So I want to know a little bit more about lactase and this whole lactose intolerance, right? So I'm thinking that being deficient in magnesium might contribute to someone being lactose intolerant. And of course, I asked the question. I said, might someone that is deficient in magnesium be lactose intolerant? And I asked Quality AI to cite relevant sources in mammalian format. And then, to my surprise, this is what it said. There is no direct link between magnesium deficiency and lactose intolerance. However, magnesium plays an important role in the absorption of metabolism of calcium, which is necessary for lactose digestion. Therefore, a deficiency in magnesium may indirectly contribute to lactose intolerance by impairing calcium absorption. And so I'm thinking that there are other things that contribute to your body's ability to digest milk. And I'm asking Quality AI, other than lactase, enumerate the other substances that help the body metabolize cow's milk and to cite relevant sources in MLA format. And this is what I got. In addition to lactase, there are several other substances that may help the body metabolize cow's milk. So basically, it's saying that calcium is necessary, and calcium helps to reduce the production of gas. And vitamin D is important for the absorption of calcium. And I'm going to ask them about vitamin K2. Vitamin K1 and K2 are both forms of vitamin K that play an important role in vitamin K1 and vitamin K2 are both forms of vitamin K that play important roles in human biology. Vitamin K1, also known as phytoquinone, is found in green leafy vegetables and is the primary dietary source of vitamin K. Its main role is in blood clotting, but where it is required for the activation of certain proteins that help to form blood clots. Vitamin K2, also known as menaquinone, is produced by bacteria in the gut and is also found in fermented foods such as cheese and nut oil. Its main role is in bone health, which helps to activate proteins that are involved in the regulation of calcium metabolism. So it's vitamin K2 helps to activate proteins that are involved in the regulation of metabolism, regulation of calcium metabolism. So I'm going to ask Quality AI to describe vitamin K2's role in the regulation of calcium metabolism, cite relevant sources in MLA format, and since vitamin K2 plays an important role in the regulation of calcium metabolism and activate proteins that are involved in the deposition of calcium in bones and teeth, and the prevention of calcification in soft tissues such as arteries and kidneys. These proteins are known as vitamin K-dependent proteins, or VDP. VKDPs is osteocalcin, which is produced by bone-forming cells called osteoblasts and is involved in the mineralization of bone. Vitamin K2 activates osteocalcin by adding a carboxyl group to the protein, which enables it to bind to calcium and to promote bone mineralization. Another DKDP is matrix glycoprotein, which is produced by vascular smooth muscle cells and helps to prevent the calcification of blood vessels. Vitamin K2 activates matrix glycoprotein by adding carboxyl groups to the protein, which enables it to bind to calcium to prevent it from depositing in the walls of blood vessels. And there you have it. There's sources. These are types of questions I ask Quality AI all the time so I can understand concepts a little bit better. If you want to check out Quality AI, there's my affiliate link in the description. I'm Spinny. I hope you reach your fitness goals, and I'll talk to you in the next one.